students, you are on to Dr. OJ's tutorial class. In this video today, we shall be talking about differentiation. Differentiation. This is an aspect of calculus. So we want to discuss differentiation in calculus. Okay? Now, suppose we have a function. Suppose we have a function f of x. So f of x is a function, and I want to discuss the concept of differentiation of f of x. But to do that, we need to show that f of x is differentiable. And for a function to be differentiable, it must satisfy a particular condition. So let y is equals to f of x be a function. Okay? Now, the function is, differentiable if its derivative exists. If its derivative exists, and for the derivative of a function to exist, its limit must exist as well. So the limits of the function or of the derivative must exist as well. Must exist. So we have defined the concept of differentiability via this note. Now let's show that in a mathematical expression, in a mathematical way. Let's show that in a mathematical way. Okay? We are very familiar with the concept of graphs. Suppose this is a graph. This is y positive axis, x positive axis. So suppose we have a curve. This is a function. So y is equals to f of x is a function. It's a curve. So you observe clearly that we can extrapolate this point AB to the horizontal. So here we have x1. Similarly here, x2. So when we come here, we have y1. And when we come here, we have y2. So you observe clearly that there is a change, between y1 and y2. That is delta y. That's change in y. Likewise, we have a change of x between x2 and x1. Now, the slope, which we are familiar with, the slope, let's say, this ABC now, let's say that's from the slope of the triangle ABC now, that's the gradient, can be defined as the rate of change, of y with respect to x. Okay? That's the slope. And basically, the slope is talking about the slope of this graph. If I say the slope of triangle ABC, I'm talking about the slope of the graph. The graph y is equals to f of x. All right. So, which we all know that it means that change in y all over change in x. So, by and large, for that function to be differentiable, the limits of the function must exist. That is to say that the change in y all over the change in x must be the limits as this delta x tends to 0 of the function f of x plus change in x minus f of x all over change in x. Okay, this is what we mean by the function being differentiable. So, this is what we meant by the function being differentiable, which we have clearly shown in the function we have just, exemplified now. That is the rate of change of x with respect to the rate of change of y. So, you can see. Now, let's now define the differentiation of a function from the first principle. The differentiation of a function from the first principle. So, the first derivative of the function, hence, the first derivative of y is equals to f of x is denoted as dy dx, that is because of the limit that has existed, is equal to the limit of as delta x tends to 0 of this. Okay, so when you take the limit of this, you get the y dx, which is the change in y with respect to x. Now, let's try to find the derivative of a function from the first principle. Derivative of function from the first principle. The first principle involves the principle of limit theory. Limit theory. That is a principle that clearly shows the differentiability of a function right from the version of the limits. That's the relation from the first principle. Let's look at an example. Now, differentiation from the first principle. Okay, now example, let's say differentiate y is equals to x squared from the first principle. We want to differentiate y is equals to x squared from the first principle. So how do we go about that? It's very simple. Let's look at it. Now, anytime you see variable y, you add an increment of y to it. When you see variable x, you add an increment of x. Don't forget the change in y we are talking about and change in x respectively. They are the main increment in y, increment in x. So we have y plus delta y is equal to x plus delta x all squared. Now I told you that anytime you see y, you add the increment to it, and anytime you see x, you add the increment to it. So now from here, you can say delta y now will be x plus delta x squared, minus y. This, what I'm seeing by delta here is not the delta we are familiar with. This is like this thing is like nabla. Okay, it's an operator, nabla hex. I can call it delta temporarily, but it's still the same thing as nabla, or it's an operator. It's a differential operator. It means change in x, it means change in y. Okay, this is actually delta. So now the change in y will now be equal to, by the time you expand this, normal expansion, x plus delta x multiplied by x plus. When you open up this, you have x plus change in x into bracket x plus change in x, then minus Now, your y originally from the problem is what? X squared. So you replace that y by the value of y given to you. Okay? Yes, you replace it by that value. So that we have y on the left and x on the right. So, now have change in y will be, when you expand this, you have x squared plus 2x delta x plus delta x all squared. If you expand this, okay, then minus x squared. This implies that this can cancel this out. Okay, so you'll be left with what? Delta y is equal to 2x delta x, and change in x, plus change in x all squared. Now, for us to get the rate of change of y with respect to x, we have to divide through by delta y, by delta x rather. Now divide through by change in x gives, then we divide through by what? Change in y all over change in x is equal to 2x change in x all over change in x plus change in x squared all over change in x. So with that division, this will cancel this out. This will cancel one of these. So you'll be left with what? Change in y all over change in x will be equal to what? 2x, plus change in x. Now, for you to actually get the rate of change of y, with respect to x, you have to find the limits. So, now say, the y, the x will be the limits as the change in x tends to 0 of change in y all over change in x. So by the time you find the limit of this function, of this rate, then you are looking for the y, the x. So which implies that limit as delta x tends to 0, that is change in x tends to 0, over 2x plus change in x. Okay? So that means that wherever you see delta x or change in x, you put 0 there. So you have what? This one now becomes, therefore, the y, the x will be, so putting delta x to be 0, 2x plus 0, which means is 2x. Okay? So that is the differentiation of that function from the first principle. Let's look at more examples. Because we need to understand this basic concept of differentiation from the first principle very well. Let's look at another example. Fine. Differentiate from the first principle. Example 2. Differentiate from the first principle. I want to differentiate from the first principle. Y is equals to 1 all over x. I want to differentiate from the first principle. Y is equals to 1 over x, where x is not equals to 0, because by the time x equals to 0, the function will be undefined. Oh yeah, let's go there. Y is equals to 1 over x. For us to differentiate for the first principle, I told you that you will add the increment of y and x respectively. So we have what? Y plus change in y is equals to 1 over x plus change in x. Beautiful. So by the time you make change in y solve formula, y will come here. So now I have what? Change in y will be 1 all over x plus change in x, then minus y. So and your y is what? 1 over x. So change in y will be 1 over x plus change in x minus, what is your y from the equation? 1 over x. Beautiful. So the next thing is now to find the LCM of x into x plus change in x. Okay? Now, x plus change in x, cancelling it out, we have only x left here. X times 1, x, minus x cancelling x out here, you have x plus change in x multiplied by 1. X plus change in x. Okay? Now, that implies that, so that now implies that change in y will be x minus x plus change in x all over x into x plus change in x. So which will be x minus change in x. When you open up the bracket, all over x into x plus change in x. Okay? Okay? I hope you are following. Yes. Okay. Now, with that, we'll be having what? Change in y will be, this will cancel out this. We have minus change in x all over x into x plus change in x. So the next thing now is to divide by change in x. Divide both sides by change in x. Now divide this side and this side by change in x. You have what? Change in y all over change in x is equal to what? Minus change in x all over x into x plus change in x divided by change in x. Okay? So by the time you say that, what follows? What follows? Let us see. Let us see what follows. Let's clean this so that we have enough space. Okay, so now I have what? Change in y all over change in x will be minus change in x all over x into x plus change in x multiplied by 1 over change in x. This will cancel this. So you have change in y all over change in x is equal to minus 1 all over x into x plus change in x. So the next thing is now what? To find the limit, now to get your dy dx. So dy dx now will be the limit as delta x now tends to 0 of your dy of your change in y with respect to the x. So you can write minus 1 over x into x plus change in x. So by the time you assume you let your delta x tends to 0, which means put delta x to be 0, you have dy dx now will be equal to, so by the time you say let your delta x tends to 0, the limit sign will disappear. You don't have limit again because that's the meaning of dy dx. So it means that when we are taking the limit of change in y with respect to change in x, we will not have change in y with respect to change in x again. We will now be having the y dx, which is the rate of change of y with respect to x. So that will give us what? Minus 1 all over x into x plus 0. So that will be what? The y dx now will be equal to 1 all over x times x, because x plus 0 is x. That's 1 all over, sorry, minus 1. Don't forget that minus 1 here. That's minus 1 all over x squared. So from the first principle, the derivative of 1 over x is minus 1 all over x squared. So let's do one more before we move into another aspect of differentiation from the first principle. Let's quickly do one more. Let's solve one more problem. Okay. Now here we want to, this is another example. Example, let's say 3. Differentiate y is equals to c from the first principle. We want to differentiate this from the first principle. How do we do that? Fine. So, you observe that this c is a constant. It doesn't have a variable x. So, that means there won't be any increment in c because it's a constant. So now y plus change in y is equals to c. Yes, because it's a constant, so it will not change. So change in y will now be c minus y. So change in y will be equals to c minus, and what is your y from the equation? Your y is c. So change in y is equals to 0. So now divide both sides by change in x. We have what? Change in y all over change in x is equals to 0 all over change in x. So you have change in y all over change in x is equals to 0. Is equals to 0. So now take the limit of both. Now, the y dx now will be limit as changing x tends to 0 of 0. You're finding the limit of that 0, which is what? Which implies the y dx is equal to 0, because 0 is a constant. So anytime you are asked to differentiate a constant, the result will be 0. So with this, we have come to the end of this first segment. In the next video, we shall continue with differentiation from the first principle. Stay blessed. Don't forget, click on the notification button so that each time I upload a new video, you will be notified.